Chuckles the Rocket Dog 1.2, Negative Exponents. So we're going to learn two more rules about exponents in this lesson, but we first start by talking about something that you've heard before, but the distinction between this first question, negative 3 squared, and the parentheses negative 3 squared. So this is an important distinction to make, especially now that we're talking so much about exponents. So the base here is 3. The negative is in front of the 3, yes, and it does look like negative 3 squared, but really the only thing that's squared here is the 3. The negative hangs out in front. The negative hangs out in front, and the 3 is the thing that's squared. So really what this says is negative 3 times 3, or negative 9. This one here is a little bit different. The parentheses are squared, so that means the base is negative 3 in parentheses. It's negative 3 times negative 3, which is actually a positive 9. That's a very important distinction to make because it will be the difference between getting a question correct or incorrect. What this lesson really talks about is negative exponents. So when the exponent is negative, and surprisingly, the answer here is 1/9. And the answer here is negative, actually no, it's still positive 1/9, which is interesting. But the thing I want you to notice here, and I'm going to explain how and why this works in the next slide, but what I want you to notice is that a negative exponent does not mean a negative answer. A negative exponent means a really small fractional number. Okay? Now, if I had negative 3 to the negative 3rd power, because my base is negative and my exponent is odd, this one actually would be negative. But you're probably thinking, I don't really understand that. You haven't explained it. So let me get to that first. Okay, 2 to the 3rd power. This should be a really simple thing that you've done in the last lesson and in the past. It's 2 times 2 times 2, or 8. Okay, 2 to the 3rd power equals 8. 2 to the 2nd power is 2 times 2, or 4, right? 2 to the 1st power is just a 2, and that equals 2. Well, if I look at the direction going up this chart, I would say, oh, I take 2 and I multiply by another 2 and I get 4, and I multiply by another 2 and I get 8. Okay, great. Now, what if I look at this a different way? What if now I'm going to look at it moving down the chart. From 8 to 4, I'm not multiplying by 2, but instead now I'm dividing by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. So then when we get to the more challenging situations, a lot of people think 2 to the 0 power equals 0. But actually that's not true, because if I follow this pattern, I'm at 2 and I'm going to divide by 2 again. You're thinking to yourself, what is 2 divided by 2? Oh yeah, 2 divided by 2 is just 1. So the 0 power is 1. And it would be really great if you had your calculator nearby and you could go ahead and indeed confirm that. Put in any number that you want. Put in 100 to the 0 power, and you will see that it equals 1. So anything to the 0 power equals 1. So I've given questions on tests before that are like 4x to the 3rd, y to the 7th times 900. And then I take that whole thing and I put it to the 0th power. I'm having trouble with my writing slate, but to the 0th power, and that would indeed equal 1. So let me give you another crazy one over here. X to the 2nd, y to the 5th times 9,000. All that to the 0 power would equal 1. Okay, so I've given kind of trick questions on tests before that try to make you think about what that might be. Okay, let's go back to our negative exponents. So one of the rules, by the way, though, you should know is the 0th power rule, and I'll outline that again for you in the next slide. Okay, so if I'm following this pattern, I'm dividing by 2, dividing by 2, dividing by 2, I'm going to take the 1 and I'm going to divide by 2 again. So on my exponents, I had a 3, I had a 2, I had a 1, I had a 0, so now my next obvious exponent would be negative 1. And if I had 1 and I'm dividing by 2, that's going to give me, go back to black, that's going to give me 1/2, right? So I'm going to write it as 1/2. Okay, and again, I'm going to divide by 2. So now I have 1/2 divided by 2. Well, what's a half divided by 2? Oh yeah, That is 1/4. Then I divide by 2 again, and I've got 1/8. So you can see how as long as I keep dividing by 2, I'm actually never going to go into the negatives. I'll always be getting close to 0, but I won't actually cross over 0 and go into the negatives. Notice the symmetry. 2 to the third power is 8. 2 to the negative third power is 1/8. 2 to the second power is 4. 2 to the negative second power is 1/4. 2 to the first power is 2. 2 to the negative first power is 1/2. Okay, do you see the symmetry that's going on? So basically, when you have 3 to the negative third power, as I did in the slide before, it becomes a fraction. 1 is going to be my numerator, and my denominator is going to be 3 to the positive third power, or 1/27th. I think I actually had 3 to the negative second on the last slide. That would be 1/3 to the second, or 1/9. The reason why it turned negative is because when I had a base of -3 and I brought it to the negative third power, it became 1 over, I'm going to run into trouble again. Let's try it over here. -3 to the negative third power, I had 1 over -3 to the positive third power, but -3 to the positive third power actually gives me a negative number, so it gives me 1 over -27. Okay, so if you're a little bit confused, just bear with yourself, okay? The main rule you need to know is that x to the negative a power equals 1 over x to the a power. It basically takes what you have, makes the exponent positive, and puts it in the denominator, okay? Makes a very small number. Okay, exponent rule number 7 is anything to the 0 power equals 1. Okay, so an example on this one would be 2 to the negative third power is 1 over 2 to the third, and then I can evaluate that further, 1/8. An example here would be 9,241 all to the 0th power would equal just 1. Okay, all right, so here let's get into some more difficult problems that you might encounter. Write the following with positive exponents only. Frequently, that's what you'll see for your directions on these kinds of problems. So you're going to have to use all the exponent rules that you used in the last lesson, combined with what you've now learned about 0 power and negative exponents, and you're going to have to figure out what this is. So I've got, first I'm going to give the negative third to both of these. So I'm going to have 5 to the negative third power times x to the negative 6th power, because 2 times -3 gives me -6. Well, that's not going to be an okay answer because the directions say write the following with positive exponents only, and these both have negative exponents. So 5 to the negative third becomes 1 over 5 to the third, and x to the negative 6th becomes 1 over x to the 6th. So actually, if I wrote this in its cleanest form, it would be 1 over, that's 125. You could leave this exponentially, or you could write it as 125 x to the 6th power. That would be the best form of your answer for that question. Okay, next one. I've got -2 to the negative 4th power. This is tricky. The negative is going to be taken to the power because it's inside the parentheses. So I'm thinking this way, -2 to the negative 4th power, x to the negative 12th power, v to the positive 12th power, because -3 times -4 is positive 12. Okay, again, I can't leave my answer like this because I need to write it with positive exponents only. So I am going to have a fractional answer. So let's think. This has a negative exponent, this has a negative exponent. So I'll highlight them both. These are both going to end up in the denominator. But v to the 12th power will stay in the numerator because it has a positive exponent. So v to the 12th stays there. Now, -2 will stay my base to the positive 4th power, and I could figure out what that is, and I probably will, and x to the 12th power would be in the denominator. If I were going to take that one step further, let's put that question down there. Okay, if I'm going to take that one step further, then what I'm going to do is I'm going to say v to the 12th is my numerator, Negative 2 to the 4th power. Well, that's negative 2 times negative 2 times negative 2 times negative 2. So that's going to be 16 positive x to the 12th power. And that is the best way I could express that answer. Okay, finally, I've got a fraction that has positives and negatives, positive and negative exponents in it. If I want to, there's several different ways to do this, and I can talk to you in class about that. But I first take a look at what I have, and I say, if I move this guy to the denominator, it will make my exponent positive. If I move this guy to the numerator, it will make my exponent positive. Kind of gave a weird example here, but they basically switch spots, and it becomes positive. Now, x has a power of 1, so it doesn't go anywhere. Y to the 3rd has a positive exponent, so it doesn't go anywhere. X to the negative 4th is a negative exponent, so it can move to the top and become positive. Y has a positive exponent, so I'm going to leave it where it is. Okay, so these are going to cancel each other out because they're just equivalent to 1. X and x to the 4th will become x to the 5th in the numerator. And y to the 3rd will cancel out, and you will get y to the 2nd. And there's nothing left on the bottom, so it's a 1. So my final and best answer here would be x to the 5th, y to the 2nd. Okay, so these were 3 examples. You're going to do many, many, many examples. And if you follow that, that's great. And if you didn't, you're going to have time to practice and process and ask questions in class. Make sure you write down the 2 rules that we discussed, and good luck in the lesson.